questions about things before we get going?
Oh,
Yes.
last time we talked about a video. I don't know.
Oh, just do, you can go to YouTube and just search my name. It'll be the first page that comes up. And then I have videos for this class on there.
Really?
Yeah.
How come? I mean, I did go to your.
Oh, I'm sorry. It was a different one. You want to do, let me show you real quick. I'm sorry. There's videos that a buddy of mine and I did for, is this? Oh, so I don't have it the right source. So go to YouTube. Still need to go to YouTube, just not my site. What I record in class, like I'm recording right now actually, you'll want to go to my site. But this is for videos for the different chapters, for some of the different chapters that we'll do. So go to YouTube and then do a search for theory interest. And then this is what other people helped me with in class the other day. Go to filter and then just do it by channel. And it'll be the first channel. And then under the playlists, there are videos for different chapters in text. So chapter 2 is where the videos were. I'm sorry, I forgot that it wasn't on my page.
Are we gonna go over number 11?
Would you like me to go over number 11?
Yeah.
I got a really big, ugly line of work and just figured it was too complicated. So.
That's too hard, I quit. That was what it
That's
was?
pretty much where I'm at.
I was a bad little boy and used my graphing calculator to find the intersection.
All right, well, let's see if we can do it.
That's the one factor to x squared. Well, I got down to this, and then I was like, it's too complicated. So I wrote that down in case I wanted to see Dr. J to ask about it.
Theory Interest has got another subscriber.
Oh, nice, yes.
I think I might have done it.
What did you do, Haley?
So messy.
I don't know. Marshall has a full page, and I have this much of a page.
That's why I think I
You want to come show?
Did you figure it out?
No, because I don't know if it's right.
It doesn't matter. You don't want to do it? Little,
I mean, I can. If you want me to. Okay, I'll do it.
okay.
Okay.
Get on the chalkboard.
I'm not going to write it again. Dr. Bear has the camera thing right there.
You want to write it on here or you want to write it on the board?
Oh, I don't care. I'll write it on the chalkboard.
Okay. It'll be,
Or I guess I can write it on there.
you tell me. I've got
No,
the
I'll do it
pen.
on the chalkboard.
I got the
That
pen
way-
right here.
That way the internet doesn't know if I did it wrong.
All right, we'll write it on the chalkboard then. I just want to see what it did.
It's probably wrong. You want to look at it first?
No.
Okay. Okay.
You have to have some confidence, Haley.
I don't remember the problem was, but I wrote that the present value at time 0 was x, and that t equals 1. Okay. Plugged in the 1, that's why there's no t's.
Gotcha.
Yeah. Okay. Now where did I go from there? Oh. It's gonna be really embarrassing if this is all wrong, you guys.
Yeah, you got way farther than all of us.
3, and I was gonna write a 5. I don't know why, because I was thinking 3. I don't know what. Oh, there was more work there. Okay, I boxed all those in. I don't remember what I was looking for. So.
This is for X, D, and I.
No, that's why I boxed all those in.
Yeah, there you go.
Where's I?
Oh, I did it wrong.
It's the middle box. I don't know if that's right. It could be very, very wrong.
Well, what'd you do?
Oh. It's this Friday feels like a Monday, like times 10. Okay, so I wrote down those, and then I used the simple discount rates. Thank you. I was gonna say deductible. That's not right. Wrote those down and plugged in like the accumulated values, because I guess that's what those. And then I wrote down the equal equation to like solve for it. And then I plugged in, like I solved for this part and the 1 minus d, and plugged in what I got. I didn't do that work. I just kind of did that in my head. And then I flipped this because, like simplified it there. And then cross multiplied and got that, and then solved for x and got 103.92. I mean, yeah. Okay. And then here I went back to the simple interest to find I and plugged in x. Then you only have one variable and one equation, and solved for I, and did the same thing here and solved for d.
Did you get the others? Did you get the system of equations set up? I was asking everybody else. Sorry, Haley.
So I misread the problem. I thought the accumulated value was x plus 108, x plus 100, and I think that's why my answer.
Oh, yeah, that would make
That's why it was so.
that would make it really bad. Yes.
Yeah, so that's what I did wrong.
So x is your present value in this case, right? Right?
Yeah.
Okay. So this would get you your accumulated value. So the amount of discount earned when an investment grows to the value x at the end of year is 100. Amount of discount earned when it grows to, making sure I'm interpreting the sentence right. Certainly what you did everywhere else here is fine. I'm just trying to make sure we have this right interpretation for this equation.
Wouldn't it just be XD and XI? Because it's the interest and discount accumulated.
Ah. Right, I think it does, yeah, because so it says if you invest X today, you get 108 in interest. And I think you made it the accumulated value. Yeah, it's all right. Well, if it was, I mean, what you did for the process is perfect. If that was what it said.
How did you get, so how can, if x is 103.93 and with an interest rate of 3.9 for 1 year, how do you get $108?
Here? You mean here?
Yeah, because if the interest rate is 3.93% and you invest $103, how does that give you $108 after 1 year?
Well, it would give you an accumulated value of $108, right? If I took the 103.92 and multiplied it by that, that would give me the interest and then add it back to the 103.92. That's why I said she interpreted this as being the accumulated value rather than the interest. Right? Yeah. Okay. So we should have the XI should be 108 and the XD should be 100 instead of times the 1 plus I and the 1 minus D, I think, if I'm reading it right. Because I misread the first part too. I read it as accumulated value. You still have your 1 over 1 plus I. Ooh, hey, that looks like a T. 1 over 1 plus I is 1 minus d, or vice versa. It doesn't matter which way you write it. The reciprocals, right? 1 plus I and 1 minus d are reciprocals of each other. But you can do the same idea here, right? You can solve the first equation for I and the second equation for d, and plug it in over here and solve. So you would have 1 over 1 plus 100. Ooh, good grief. Maybe I should just not teach today. 1 minus 1 over, or 1 minus 1 over, 1 minus 100 over x on the right-hand side. And then at that point, you should be able to solve for x. And once you get x, I and d are easy. Right? It's getting the x that's the more difficult part. So, yeah, so at this point, you just need to multiply or simplify things as much as you can. Whatever you'd like to do it. Multiply top and bottom here by x, maybe. And then multiply through by x again to get rid of the x on the other side. Yeah, maybe not. The multiply top and bottom by x, you would get x over x plus 108. Yeah.
If you change the one on the right side to x over x,
Yeah.
minus 100.
Yeah, so x over this. And then you could do your cross multiplying again. If I did, oops, that's a plus. If I did my foiling correctly on the right hand side, if we cross multiply.
What'd you do on the right hand side?
I just got a common denominator.
X minus 100?
Just got a common denominator.
So 1 equals x over x. So you have x minus 100.
So then you should get your, you should have 8x is equal to 1,000 or 10,800. Which makes your x what? 1350. Cool. There you go. And then you should be able to figure out I and D from that. The first two. You did what you were supposed to do if you had read the problem that way. If you had the accumulated values of those things. Just read it. No, and that's a lot of what this particular exam is reading. So that is one of the things to practice. It's making sure we're reading the problems correctly.
The example was, isn't it?
Yeah, my guess is, no, I'm not going to guess. They might have given you that answer. My guess is that the actual correct answer being 1350 probably wouldn't have had something that low. Usually when they give the answers, the correct answer is in there and they have equally spaced other answers. That's usually how they write it in there.
Some of them will throw out answers to begin with.
Yeah, some of them will, but a lot of the times it's just, you'll see like 20, 40, 68, 100. It's just all, they're all evenly spaced. What's that?
So at least you finished the problem.
Hey. Well, and you equated the two to get the x value, or the x by itself, so you could solve for it, and that was the technique to do it. So, thank you for putting it on board. I appreciate it. That makes sense for you.
Gotta get those participation points somehow.
That's right.
We get graded on participation.
You get graded on participation.
Since when is that a thing? Is that just for this class? Or is that always a thing?
You realize we're being sarcastic, right?
Oh, okay. No, I did not realize.
That's funny.
Attendance was a grade in Dr. Joe's class. Some days I don't know.
What's that?
I said if attendance was a grade,
Oh.
I might have failed. A couple classes.
I wouldn't know I do.
What?
I said, how wouldn't know I do?
Honestly, he probably still managed to pass the class.
Yeah,
ask him about 3D printing, see how he did.
Oh, jeez.
I think that one was a participation class.
I heard about that.
Also, did we miss the final?
That was what I heard. Other questions before we go on to new stuff? The other problems go okay?
So for this one, it says like you earn discount, but you earn interest at the same time or something?
So this particular problem, you mean?
Yeah, so like, it's saying like if you invest, you earn interest and discount at the same time?
Yes. That it's just a different way to think about it. Because remember, the interest that you earn is calculated off your present value. The discount that's earned is figured off of the accumulated value. So it's the same amount. It's just computed off of two different values, which is why the rates are different. I know it's kind of weird, but it's how it's phrased and how it works in these particular problems. Anything else? All right, well, let's go on to actually compounding some interest. So let's talk about chapter 3 and then work on some problems. Go ahead and hand out some extra problems here from an exam FM review manual.
Yeah. One packet was not enough. What? So one packet was not enough.
Oh, you're going to get a lot of copies from me this semester. I get problems from all over the place. I don't want to think about myself.
I wasn't there.
Uh-oh. May have given out my copy.
Okay, whose copy has all the answers?
I'm trying to figure out. One of them has marketing. Did anybody say one with marketing on? Oh, no, that's up here. Never mind. I just want to make sure you can point mine out. Because I marked which ones I want to do for examples. That was why I didn't want to give up my copy. I didn't actually give the answers on it. It was just, this is the one that I want to do for examples. All right. So, you've probably seen the derivation before, but when we're doing compound interest stuff, you base it off of your simple interest and then worrying about how the interest gets recomputed after each period. So, we know that for accumulated value at time 1, for simple interest, that would be your present value times 1 plus I times a 1 there, right? We agree? Now, one of the problems that was in that extra packet from last time, I believe it was the Leonard and Sheldon problem. One of them took money, put it in for 2 years at simple interest. One of them instead took the money, put it in for a year at simple interest, and took it out and reinvested it, put it in for another year. So the interest would get computed on both the original amount and the interest that was accumulated, right? So that's the same concept we would do here. So if you wanted to do the accumulated value, assuming we do compounding, the accumulated value at time 2 would be your value at time 1 times another interest period, right? We agree with that? But we already figured out what this is. That AV1 is your PV, and I'm going to suppress the other ones that are in parentheses. Your present value times 1 plus I times another 1 plus I, and you get 1 plus I squared. Right? We agree with that? Everybody's quiet, so I'm going to assume we agree with that. Okay? And then just to do one more here. Oops. I did AV3. Okay, so again, think about it as you're doing simple interest, but after each time your interest is computed, you're taking the money out and reinvesting it. So it's your new present value. So your AV3 would be your AV2 times 1 plus I. But AV2 was the present value, 1 plus I squared times 1 plus I. So you get 1 plus I cubed times the present value.
So each one, the PV becomes the previous thing.
Yes, and each one of the PV begins with the previous AV, right? Because we're reinvesting. That's exactly right. So at this point, we start to see the pattern. If you wanted to do an actual formal proof, you could do an inductive proof on this, mathematical induction to prove it. But you can see the pattern, right? For one time period, the exponent is 1. For 2 time periods, the exponent is 2, and so on down the line, right? So in general, your AVT will be your present value times 1 plus I to the t. Now we can come up with a similar formula for discount. It would be the same idea for being able to reinvest, plug back in, and change your simple discount to a compound discount. And I'm just going to end up writing that formula down in a minute. What's important here is your time periods matching. You'll see several problems as we go through, not just in this chapter, but several chapters past this one, where your interest rate will be quoted for a one-time period, and then you're going to be asked about present value or future value in terms of a different time period. So what's important is that whatever this t is measuring here, this interest rate here has to be in the same units per that time. Okay? So this I we refer to as the effective interest rate per period. In many problems, that interest rate might be annual effective interest rate. And a lot of things will be asked to solve for the annual effective interest rate. But they also have something that's referred to as a nominal interest rate, which we'll talk about here in a little bit. All right. So let's see if we can do an example. Well, maybe I'll do an example. Did I pick one out? Yeah, no, it's all in terms of the changing the interest rate. So maybe I'll do a little bit more of a definition here in a minute. So again, the important part is that this has to be matching whatever this t is. So if t is talking about a certain number of months, then this needs to be a monthly interest rate. If t is talking about a certain number of quarterly periods, this needs to be a quarterly interest rate, and so on down the line. Okay? So we'll have to know how to do conversions of these things based on what the number of periods are. So let's talk about that for just a minute. So sometimes you'll see what's referred to as a nominal interest rate. And I think instead of writing out a big long definition, let me just give you an example. Just write one down. So as an example here, say you've got a nominal interest rate of 8% compounded. You'll also see the word convertible, and those words are synonymous. Compound or convertible quarterly. All right, so that interest rate, you assume that when they quote you an interest rate, it's talking about the interest rate per year, unless you're told about it gives you an interest rate per some other period. So if you just see a rate, it's going to be assumed to be a yearly rate, unless they tell you that it's not a yearly rate. So that 8% is a yearly rate. Okay? However, it's not the effective interest rate. What that means is that instead of that interest rate being compounded each year, that interest rate is actually being compounded each quarter. Okay? So what you do with that 8% is you're going to divide it, since it's a nominal rate, you're going to take that 8% and you're going to divide it into 4 pieces. So that nominal interest rate of 8%, compounded quarterly, we use a superscript in parentheses here to denote that we're talking about a nominal interest rate. Okay, so we use I a lot for annual interest rate. When we do the superscripted part here, it's telling us, oh, this isn't an effective rate, this is a nominal rate. This is telling us how many periods there are in the year that we're going to be compounding this thing. Okay? So since it's compounded quarterly, that's what that 4 means. Okay? So in this example, that I4 is 8%. That's the nominal rate. But the interest rate per quarter is going to be I4 over 4, which will be that, I'll write it as 0.08 over 4, which will be 0.02, or 2% per quarter. Okay? You okay with that? Now, if you wanted to make this, it says it's a nominal rate of 8%. If you wanted to figure out what the effective rate is, effective annual rate is, we could figure that out. The way we would do that is, well, we know that that interest rate is compounded per quarter. So if you invested $1 at time 0, what would that grow to after the first quarter? $1.02, right? It was 2% per quarter, right? So your dollar would grow to 0.02. This is now your new present value, and you would take a 1.02 times 0.02 to find your interest and add the 1.02 back to it again, right? So and then you would do it again for the third quarter, and then do it again for the fourth quarter. That's just compound interest, isn't it? So if we wanted to figure out the annual effective rate, you would take your 1 plus your quarterly interest rate, so that I 4 over 4, raise it to the 4th power, because that would this would be your accumulated value of $1 after 4 quarters, right? And when we talk about the formula, this has to be your period effective interest rate, which is 0.02 in this case, right? We agree? This would be how many quarters? So this would be your accumulated value of $1. But if I want the amount of interest for that 1 year, what would I need to subtract off here? I need to subtract off, the present value, right? I need to subtract off 1. And I had to get the amount of interest, I had to subtract off what I invested, right? So then we do minus 1 here. So in this particular case, you would have 1.02 to the 4th minus 1. Whatever that is. Thank you. 0.0824, so 8.24%. Is that what you said? Yeah. Okay. Does it make sense that the effective interest rate should be higher than the nominal interest rate? Yeah, sure does, right? The nominal interest rate, remember we thought about just dividing it into pieces. Now, if this were simple interest rate, it would be exactly the same. Right? If you did 2% simple interest per quarter, that would be the same as 8% simple interest for the year. Because it's only ever computed on that original value. Right? Because you would have 1 plus I times 4. No? 102 times 4 is 0.08. Would give you the same value. But in this case, you're compounding the interest. So it makes sense that the annual effective interest rate is higher. To give a specific example, if you go online to a bank and look at their mortgage rates, they will give you a quoted interest rate for the year, and then they will give you an APR, which is your annual effective interest rate. Because when you do mortgages, they compound your interest. Well, monthly, what they say, they actually calculate it depending on the average daily balance thing, so it's a little screwy, but compounded monthly ends up being a higher rate of what you actually pay than what they quote you. Because again, they're taking that interest rate and they're dividing it into pieces. Does that make sense? Right. So this actually starts to tell us how we can start converting things back and forth to different interest rates. And we'll practice that a little bit. But now that I've actually told you what nominal interest rate is, let's go to and do number 2 here on that extra packet that I gave you. Notice that, I grabbed this from a review manual. They actually grabbed a problem. When they made the review manual, they actually grabbed a problem from a sample exam FM exam. A sample exam FM exam. That was weird. A sample exam for FM. How about that? Okay. Eric deposits 100 into a savings account, pays a nominal interest rate of I, compounded semi-annually. And it wants us to figure out what I is. Now again, when we're talking about nominal interest rate of I compounded semi-annually, in that first part we would write that as I2, right? This is a nominal interest rate compounded semi-annually. Okay. So I know I'm going to need that part because it's talking about Eric doing something depositing money at that rate. Mike deposits 200 into a different savings account at time 0, which pays a simple interest rate, a simple annual interest rate of I. And then it says Eric and Mike earn the same amount of interest during the last 6 months of the 8th year. All right, so let's concentrate on that last statement in terms of each person. In particular, let's do Mike first because we did simple interest last time. Simple interest, again, all we need to know is the interest rate and the time, right? We have 1 plus IT, correct? That was what our accumulation factor was. In this case, it says the amount of interest, right? So really, we just need IT. That gives us the amount of interest, doesn't it? In this case, we don't know I. What's T going to be if we're talking about the last 6 months of the 8th year? What's T going to be? Well, we're doing the last 6 months of that 8th year. Yeah, there we go. I like that one better. It's just a half, right? Because remember, it doesn't matter when the time period starts. When we calculate the interest, we only have to worry about how long it lasts. So it's just going to be 0.5 times I. So for Mike, the interest for the last 6 months of the 8th year is just going to be 100 times I times a half. So it'll be 50 I. You could have done it in terms of accumulated value, right? You could have also done the accumulated value at the end of the 8th year minus the accumulated value at the end of the 7.5 year.
Says Mike deposited 200. Why is it 100?
Because I wrote the wrong number. It should be 200. Sorry. The first, Eric deposited 100, yes?
So it should be 100.
Should be 100i, yes. Sorry about that. Thank you, Nick. It does say 200 right next to it. Thank you. Are we okay with that interest amount? Again, you could, like I said, you could have also got this 100 by doing 200 times 1 plus 8i minus 200 times 1 plus 7.5i. The accumulated value at time 8 minus the accumulated value at time 7.5. It would give you the same number. But actually thinking about it this way is important to be able to do it for the next person, for Eric. Okay? Because it also says the amount of interest earned for both of these is the same. Notice that there's not an easy formula for calculating interest when we're talking about compound interest. Right? Right? It's not an easy formula for it. Like when we did the effective interest rate back before this example started, we had to do accumulated value at time 1 minus the present value, or accumulated value at time 0. Right? To figure out the amount of interest. So we need to do the same thing here. So what's the formula going to look like for Eric in this case? Use the same idea except for compound interest. What's the formula going to look like for Eric? That superscripted 2 and then divided by, I'm not going to put the superscript on there because it said it was the same for the both of them, but you're right. In general, it would be I2 over 2. Okay, to the 16. So this would be the amount. Yep. Okay, cool. Yeah, I agree with that. That would be the amount of interest. Well, what is it? So that would be the amount of interest, right? Because that gives you the accumulated value after the end of 8 years. So the 16th semi-annual period minus the accumulated value after the 15th semi-annual period. So the amount of interest earned during that during the last 6 months is the difference of those two values. And it says that both of those things need to be equal to each other, right? So we would have that, 100 times 1 plus I over 2 to the 16th minus 100 times 1 plus I over 2 to the 15th has to be 100I. And you're not going to be solving that one by hand, at least not easily. I can divide both sides by 100. It's just that the formulas themselves are kind of nasty. Yes? Because remember that the time in the exponent has to be the same period length as the interest rate. So that I over 2 is a semi-annual interest rate, the exponent has to be semi-annual periods. So year 7.5 is 15 semi-annual periods. So that's why the exponent is 15. Yeah. Okay. So again, the period has to match as far as that goes. So this one, again, you're not going to be able to solve this by hand. And again, you're not going to have a graphing calculator on exam.fm. So you would, literally what you would do in this particular case is take the answers I gave you and plug it in and see which one works. See which one actually give you equal. So you literally just have to plug in the numbers and see what happens. There is no other better way to do that in this case. Luckily, there's only 5 answers. And honestly, once you get used to these problems, this problem would have taken you 15 seconds to set up after you figured out what it was asking. It's really not that bad of a problem. Hey, how are you? How's it going? Good. You're gonna sit and listen to the theory of interest? Oh, okay, fine. So yeah, in this one you would just have to plug and chug and see what happens. There's not a good way to do it. Now, a lot of times using your calculator, if you're asked to find an interest rate, this is atypical. Either you're able to do this on your calculator, using the business calculator, the BA2, because there's a way you can solve for interest rate on the BA2 calculator in certain situations. Or you'll be given a situation where you use a quadratic formula to solve for it. But in this particular example, there's not any really good way for it. So since you have 5 answers, you can just start plugging them in and see which will work. Maybe I actually get it? See? Okay, cool. Was that C was the answer, or you were telling me yes in Spanish?
C.
Does that make sense?
Yeah, I got the same.
Good. Well, I like confirmation. That's awesome. All right. Yes.
So for these problems, when we mark the I, it doesn't matter what the superscript is, it doesn't like the power or anything.
It's not a power. It's just a superscript to tell. It's just a notation to tell you that you're taking the nominal rate and dividing it into that many pieces. And that's why we put parentheses around it so that we emphasize that it's not a power. It's not a great notation, but it is what they use. Well, we're going to see a lot of that this semester. It's not a great notation, but that's what they use. Okay. You can do the same thing for discount rate. Like I mentioned, you can do the same formula. So if you have a discount rate given to you, it's analogous to what we did for simple interest, but you'll do with compound interest, so that your present value, your PV, will be your accumulated value at time t times 1 minus, I'll write it as dn over n, oops, to the t power. So your dn would be your nominal discount rate, so that you're dividing it by n will give you your period effective discount rate. And then t would be the number of periods. So your period that your t is given in has to match your period effective rate. Does that make sense? Are we okay with that? You would generate this formula just like we did with compound interest, by the way. It's a similar way. It's an inductive idea. Just notice that instead of this being written next to the PV, it's written next to the AV, right? Instead of a plus sign in the middle, it's a minus. Okay. So let's see if we can do one with discount rates. Pardon me. Let's look at number 3. Number 3, you're depositing $10 today, $20 15 years later. You're going to do a nominal discount rate compounded quarterly for the first 10 years, and then a nominal interest rate compounded semi-annually past the first 10 years and then forever after. And it tells you what the accumulated balance is at the end of 30 years. Pardon me. And it wants us to find out what D is. Okay. Pretty indicative of a type of problem in this particular section, but in the exam in general, you got this multi-step idea that we need to do. Right? So what I would do or what a lot of review manuals and textbooks would do, is start generating what we refer to as a time diagram to see what's going on and see what we need to do. Okay? So a time diagram looks like a timeline. We're going from 0 to 30. A lot of times we would put extra tick marks in the middle, but in this case, we know a couple of different time periods or different time values where something is happening, right? Something happens at time 10. Something happens at time 15, right? We agree? Okay. We know that at time 0, you're putting in, you're putting in $10, right? We agree? Then that $10 has to get moved to time 10 using a discount rate, right? We agree? And then time 30 using an interest rate. I'm not worrying about the second deposit yet. This is just the first deposit, correct? So the 10 gets moved forward with your discount and then the interest rate, right? We agree? Now, a lot of times in these time value diagrams, you're not going to be drawing the arrows in there, but I'm just doing it for emphasis, right? Why am I moving it forward? What's the other piece of information we're given in this problem? We're given the value at time 30, correct? Okay, that's one of the reasons why I'm moving it to time 30. You agree? All right. So let's just think about, well, if we wanted to move 10 from time 0 to time 10 with the discount rate, well, what would I do? Well, 10 is a present value, right? So to get to an accumulated value at time 10, I would need to move this to the other side, wouldn't we? So if I want to do the accumulated value for the 10, I would do 1 minus D4 over 4. It was quarterly, right? Nominal interest rate compounded quarterly, correct? So it would be D4 over 4. What would the exponent be? It needs to be, okay, so this is a quarterly rate, right? So it's going to be 40 quarters, but notice I had to move this to the other side, so it wouldn't be positive 40, it would be negative 40, and move it to the other side, right? Right? We agree? So that's $10 getting pushed forward to time 10 using a discount rate for 40 quarters. Then where else do I have to go? I got to go from time 10 to time 30 using what? The semi-annual rate of, say, the 6%, but that's compounded semi-annually, so I would do 1 plus 0.06 over 2. And then what would your exponent be? 20, because it's 20 semi-annual periods, right? From time, not 20, it would be 40, right? It's 20 years, but there's 40 semi-annual periods, correct? Going from time 10 to time 30? We agree?
Are we multiplying this together?
Yes, because this is going to be your new present value to this accumulated factor. So yeah, you're multiplying those things together. Then we had one other thing, and I know I'm out of time. We had another $20 invested at 15 years later. I also need to move that forward to time 30. So what's that going to look like moving $20 forward to time 30? Power of 30. Yep. So the first expression, that first product gives you moving time $10 to time 30. The second expression gives you moving $20 to time 30. When I do that total accumulated value now, what's that supposed to equal? 100. So now do you think you could solve for D?
Well, if we subtract the last part.
Yeah, subtract the last part over and divide some stuff over, take the flip it, take the 40th root, move some stuff around, you can get there, right? Actually, that was not bad algebraically. So what we actually have created here is what your book refers to as an equation of value. They call this an equation of value. We have equated two different things at the same time. That's all the equation of value means, right? Now notice we chose to do this at time 30. You could have, another logical place to have done this would have been at time 0. Move everything back to 0. I think going to time 30 was better because we only had to worry about the discount rate in one spot, right? If I were to move everything back to 0, I would have to take the 100 all the way back to 0, which means I would hit the discount rate here. And I would have to take the 20 back to 0 and hit the discount rate here again. You'd have it at two different spots instead of one. But in this case, you should be able to solve for D without too much difficulty. You don't have the 48th root on your calculator, which is not hard to use a calculator, right? We actually do it. It's fine if you didn't do it. It's okay. Because we're out of time anyway. I'm going to be here anyway, but as far as this goes, we can call this good. If you're here for probability, you can stay, obviously. And if not, it's time to go.